every international space station with that bald fucking idiot who's acting like he's in space, he's always doing backflips. Oh, look at me, I'm in space. I'm gonna do a backflip. Woo! See, I'm in space. You can't do a backflip unless you're in space. Woo! You can't do a backflip if you are in a harness and have a green screen. You can only do a backflip in space.
Oh, it's our honor. Scott Kelly from space, everybody. We'll be right back. Oh! And he nails it.
Hello everyone. So I just watched the Flat Earth Assholes video about the ISS, and it just hit me. I've had an idea regarding how the astronaut Scott Kelly was able to do a backflip. I mean, if he wasn't really where he mentioned in the ISS in space. So the chances are like this: Scott Kelly was either where he mentioned in the ISS in space, or he found a way to somehow fake his backflip here on Earth. So for that to work on Earth, you would have to do what the Flat Earth asshole mentioned, to use a harness which keeps you at the same level, or doing it in another way, in the way that I will describe it in the next 3D scene. So I have created this somewhat simple 3D scene where we have two cameras and two biped objects which are encased in a sphere which has a bright color green. This is a green screen which is all around our biped, and inside each sphere there is a biped object and a camera which is positioned at close to the to the edge of the sphere. So let me show what's inside these spheres. I will hide them. Okay, so we have here bipeds and the cameras which were used. So you can see the two cameras. Okay, so these cameras will display their output in these two screens. Okay, so in one of the cases the biped will rotate around its weight center, and this would be the case where the biped is actually held with the harness. Okay, and in the second case, the second way to achieve this effect is to rotate the camera around the biped. So this will be demonstrated. We will look at this screen first to understand how the two cases function. So let me go frame by frame and show it. So at the right, the biped is rotating around its weight center while the camera sits motionless, and in the left sphere the camera rotates vertically around the motionless biped. So after completing this, we will see that the same effect will be achieved in both cases. Now we go back to the to the other viewports, the one with the first camera and the one with the second camera. One of them, as I mentioned, will have the biped motionless and the camera rotating around it, and the other viewport will have the camera motionless and the biped rotating around its weight center. So let me unhide the top of the sphere, so the green chamber will be completely covered. And now let me run the animation and watch what happens to both the viewports, the top left and the top right viewports. So look closely, that the same exact effect is achieved, frame by frame. Okay, so I guess that this is all. If you ask me how would someone fake this, I would choose the second case, where the camera rotates around the motionless biped, because you don't have a harness, you don't have wires to keep the biped not falling down, so maybe it's easier to fake when the camera rotates around the motionless biped. So that's how I would do it, and I would probably assume that this is the way that they did it if they faked it. Okay, so thanks for watching.